Alright, so now we're going to talk about our horizontal asymptotes. Okay, so these are our lines that go horizontally. So, next slide. Alright, here we go. Alright, so here's the first graph. Okay, so down at the bottom it says if your m is less than your n, then y equals 0. Okay, so m and n, this stands for your degree up top, degree on the bottom. So if your numerator's degree, the largest exponent, is smaller than the bottom, then you get one at y equals 0. If the top's bigger than the bottom, there's no HA, and if they're equal, then you have to divide the leading coefficients. All right, so in this case, we have our degree of 1 up top and the degree of 1 on the bottom, so we have m equals n. So we're going to take and we're going to divide what's out front, those leading coefficients, 2 divided by 1. So we do that, and we end up getting an HA at y equals 2. So if you go and draw that horizontal line, 2 up from the x-axis, that's the horizontal asymptote.
And we'll show you on the next slide, but asymptotes are always represented by a dashed line. So we'll go through a couple more quick examples and then show you what all this looks like.
And you had this introduced a little bit when we were looking at exponential functions.
Yeah, definitely. Okay, so another example here, finding the horizontal asymptotes. Now this one always causes trouble with students. Notice in the numerator, m equals 1. Denominator, this is where the trouble spot is. It's not 1. I know it might look like it's 1, but remember this is actually multiplication, so the value of n is actually 2 because x times x is x squared. So be really careful. And then in this case, m is 1, n is 2, so m is less than n, so that means we've got a horizontal asymptote at y equals 0.
Alright, so we've covered 2 out of 3 options. I wonder what this one's going to be.
I don't know.
Sheesh.
I don't know. It's got to be some trick. I don't know.
Yeah, probably. Alright, so up top, exponent. Biggest exponent's 2. Bottom, biggest exponent's 1. So 2 bigger, and this top is bigger than the bottom. That means we have no HA, no horizontal asymptote.
There is no horizontal asymptote. Okay. So what does all this look like? Here's an example that you would come across all the time in a textbook or a test. Of course, you want to factor it. You want to look for.
And if we're looking at HAs, we got to look at that degree up top and bottom. We notice is we got 2 equals 2, so that means based on our rule, we got to divide by the leading coefficient. So that's what we'll do.
Yep.
Right.
There's that. Just to refresh. And then, so when you can cancel out the x plus 1 over x plus 1, this is all the leftovers. So that's in simplest form. And take a look at what it all looks like on the graph. Okay, so we've got, here's a hole. Well, where is that hole at? Okay, remember we crossed out x plus 1. So a negative 1 makes the hole. So here it is at x equals negative 1. Physically, there's an actual hole in the graph. It's a point of discontinuity. So you can't have a line that goes through that point. It needs to be represented by a hole.
Alright, and we also have on the bottom, we have another problem when x equals 1, because that'll give us a 0 in the denominator. So at x equals 1, because it doesn't cancel out with an x minus 1 on top, you get a vertical asymptote. So this is represented by that dotted line that goes up and down there.
And then last thing, remember with our horizontal asymptotes, if the degrees are equal, you divide by the leading coefficients. 1 divided by 1 is 1, so there's a horizontal asymptote, a dotted line at y equals 1. So that's what all these graphs look like. Anything else to sum it up, or is that pretty much it?
No, and you can always take this original equation, put it in parentheses in the y equals, hit divided by, put this one in parentheses, go to your table. That'll give you some of these points. If you look at negative 1, it'll say error. If you look at positive 1, it'll say error. But if you look at 0, it'll give you 3. If you look at 3, it'll give you 0. There's just some other points that may work. This will give you a good idea of where things are. You can label this point, this point, this point, and just sort of maybe eyeball some of these other ones to get a general path. That's what you're going to want to do when you graph these things. So, yeah, I guess that's just about it.
That's about it. So we'll see you tomorrow. Good
right.
luck. Come with questions.